Yeah, good morning, children. So, welcome back to the next part of the video of lesson magnetic effect of electric current. So, already we have learned about the working principle of working principle of motor. So, said in the board itself, whenever a current carrying conductor is placed in magnetic field, it experiences an attractive or repulsive force. On this principle, actually, the motor works. So, already I told you how this setup works actually. So, this is to know the principle of working of motor. So, whenever a current carrying conductor placed in a magnetic field, it experiences a force. On this force, actually, the motor works. So, we'll see the parts of the motor and then understand the working of motor by Fleming's left hand rule. Fleming's left hand rule. So, construction of motor. How it is constructed. So, for the construction of motor, we need magnets, two powerful magnets. Two powerful magnets we need. So, two powerful magnets, in between this there is a magnetic field. So, magnetic field will be there. So, what are the different parts actually? So, one is magnet. So, magnets, powerful magnets we need. Then we need armature, a rectangular coil of wire. Then we need split rings, split rings. Then carbon brushes, carbon brush we need. Then we need. So in the external circuit we have source of electricity. The battery. Source of electricity. So, two powerful magnets are needed to construct the motor. In the motor, every motor will have two powerful magnets. In between the magnets, see, armature. Armature is a rectangular coil. A straight wire. It is coiled in a rectangular shape, and it is kept inside the magnetic field. See here, a straight wire, it is coiled in a rectangular shape on a metal. It is coiled and kept in a magnetic field. Whenever a current carrying conductor placed in a magnetic field, this is a conductor, coiled conductor. So this is called armature. Is a coil. It's a coil of wire. So both this free end of this coil is connected to the split rings. Connected to the split rings. So this is armature. This is split ring. This is S2. This is S1. Split ring 1. Split ring 2. And splitting is attached to the carbon brush. So carbon brush 2, carbon brush 1. Then, so carbon brush, this is attached to the external circuit. This is connected to the external circuit. See, this is battery and source of electricity. So this is a conductor, wire or conductor. This is the all the parts of the motor. So a motor will have two positive magnets. In between the magnet, a coil of copper, insulated copper, a coil of insulated copper wire is placed as armature. Is made as armature, and two end of the wire are connected to the split rings. Split rings S1 and S2. And this split ring S1 is connected to the carbon brush 1 and split ring S2 is connected to the carbon brush 2. Understood? So here the carbon brush and the split rings are connected like that, they can slide. Means these are not actually attached. These are not actually attached. This carbon brush and the split rings are not actually attached. They are just kept like this because the split ring has to rotate. This will rotate actually. Understood? This will rotate. That's why this is kept freely. Means it slides on that. Actually, this carbon brushes are made up of graphite. Carbon brushes are made up of graphite actually. Carbon brushes are made up of graphite. So you may be wondering, like carbon is actually a bad conductor of electricity. So that's why the graphite is used, that is a good conductor of electricity. Moreover, graphite is having high melting point. High melting point. High melting point. So when it is rotating, now it creates a friction. So what happens here? That's why they have placed their material which is having a high melting point. That is, and it must be a good conductor of electricity. That's why the graphite is placed over here. Graphite carbon brushes are placed over here. So actually this works. So here, this working of this motor is understood by Fleming's left hand rule. Fleming's left hand rule. Fleming's left hand rule. So see here, left hand. So you have to arrange these three fingers, thumb, forefinger, and the middle finger, such a way that they are all perpendicular to each other. This is perpendicular to this. This is perpendicular to this here. So this forefinger is perpendicular to the middle finger, and thumb is perpendicular to the forefinger. Like this, should be perpendicular. So Fleming's right hand rule is used to understand the working of the motor. So here thumb tells about the direction of force acting. Tells about the direction of the force acting. I told you, whenever a magnetic, current carrying conductor. Now current is flowing here. Current carrying conductor is placed in a magnetic field. Here the armature is named as ABCD. The current flows from here. Then it comes to the D, then to the S2, like this. And it rotates. So here actually. So this thumb tells about the force on which direction of the force acting on this armature. So then forefinger or index finger. Index finger is this. This tells about the direction of magnetic field. Direction of magnetic field. And last one, this middle finger. What it tells? So it tells about the direction of the current. Direction of electric current. So this can be asked for 2 marks. Write about the Fleming's left hand rule. They may ask this question. So if I apply, see, Here, when you switch on this, switch on this. So battery current flow from the battery current flows in this direction. In the external, this is external circuit. External circuit, the current flows from positive to negative. So here, the current flows to first to the C1. So carbon brush 1, then to S1. So S2, slip rings. Then from the slip ring, it goes to the armature A. So armature A, then B. So here we apply. So we can say, I will just apply, say like this I apply because this is not a 3D picture. This is a single dimension picture. So I cannot do like this. So that's why I'm doing like this here. This finger, the forefinger, sorry, middle finger tells the direction of the current. So you think that the direction of the current is like this now. Current is like this. So that's why I'm facing like this. So current is, so this is magnetic field. So magnetic field from north to south, it indicates current is indicating like this. The force acting downwards. So when current is flowing in a AB arm, so AB, a force is acting downwards. AB is pushed downwards, and CD comes here now. Here, it is flowing. Understood? So here on magnetic field already is that, and current carrying conductor also produces magnetic field. This magnetic field creates a force. So downward force in case of AB arm and CD upward arm. See, if I apply this, see, can apply now. The current is flowing this side now, downwards. So current is flowing downwards. This is magnetic field, and this is force acting. So it is coming like this. Say, AB is moving downwards and CD is moving like this. Understood? So here what happens? AB, current flows from AB, CD, then to the S2. So what happens here? The splittering changes actually. S1 will be contacting with the C1. So this actually what happens? The split rings actually help in the changing the polarity of the current. So polarity of the, see next in the next, so CD is here now, BA is here, AB is here. So current again starts flowing from the B itself. So see in the first half rotation, it was flowing from C1, then S1, then ABCD, and from there to S2 and S1. So because of this splittering is also called as commutator. Splittering is called as commutator. Commutator actually reverses the current. So here what happens? The splitting changes here. Splitting, this S2 comes with the contact with the C1, and S1 comes contact with C2. What happens? The current flows from the battery, goes to the C1 and S2. S2 to, now it becomes a DC BA. In the second half rotation also, the current flows from, so S1, S2 to, from CD, BA, then moves to the splittering S1. So here always the rotation happens anti-clockwise. Anti-clockwise it rotates. Anti-clockwise it starts rotating. Understood? This is how actually the motor works. Understood? So a current carrying conductor placed in a magnetic field, it experiences a force. What type of force? Both equal and opposite force. Here first, in the first half rotation, AB was going downwards, CD was coming upwards. The next half rotation, CD is going downwards and AB is coming. So like this, it goes on rotating continuously. It goes on rotating. Understood? So the power of the motor. The power of the motor depends on, the strength of the motor depends on the powerful magnet. If you are using the powerful magnets, more mechanical force can be felt. Understood? So in the fan, see when you are sitting on the fan rotates. You change your regulator. In the regulator, you will have a speed, control of speed. Control of speed is nothing but electricity is more sent more. 1, 2, 3, 4, 5 like this. Regulator will be there. So like that, it depends on the powerful magnets. So large motor will have those large magnets. Similarly, the mechanical force experienced in a motor depends on the coil, number of turnings on the coil. You know, inside the motor there is a coiling. Copper wire, insulated copper wire is winded. That winding, number of turns in the winding depends on that. The force experiences depend on the number of coiling. Then how much electricity we are providing? How much electricity we are providing to the motor? On that also the mechanical force depends. Mechanical force depends. So this is about the working of motor. Read the concept and try to understand the concept and correlate what is taught here and in the textbook. Understood? So if you have any doubt, please ask now. Or if you understood the concept, please raise your hands. Yeah. So I hope you understood the concept. Please read and correlate with whatever you thought in the text, whatever I thought, and correlate with the textbook content. Understood? If you have any doubts, you can call me. Okay. Okay. Thank you. In the next class, we are going to study about the electromagnetic induction, and working of generator. Thank you very much. Have a nice day.